Hello everyone, this is Professor Lee. So we're going to continue on this video lecture, and this time we are going to check um, chapter 3, right? So let's see. So chapter 3, they're going to talk about in descriptive statistic numerical measure, and in numerical measure we're going to talk about two different things. One is measures of allocation, and the other one is measures of variability, right? Measures of location first. So measures of location, basically this, we try to come up with numbers. It could be one number, it could be several numbers that best describe the entire data set. Now let me repeat that again. We try to come up with either one number or several numbers that best describe the entire data set. Now these first three, mean, median, mode, these first three is to describe entire data set with the single number, and percentile is another measure that describe a location of data points, and quartile is also another measures that they use describe the data set. Now let's it says it's a sample statistic. So if you have any type of number from group of sample, then it's called statistic value. Versus if you have any type of number, like it could be mean, it could be median, it could be anything, any type of number that you extract from population, then you call parameter. So sometimes they say it's a sample statistic, or sometimes they just say statistic. Likewise, sometimes they say population parameter, or sometimes they simply say parameter values. So if they say this is the parameter value, which means the value that you see is the value that they got, or whoever extract that value from entire population, right? All right, let's talk about the mean first. Mean is also known as average in usual common sense. Same thing as the average. But in statistics, we don't call that average, we call that mean. And mean provides a measure of central location. Try to come up with a single number that describe the entire data set in the best way, and mean is one of the number. So you add everything in the data set and divide by the number of data point in the data set. That's a mean, right? Mean, or the average that we used to know. And we call that as a point estimator. We call that X bar is a point. X bar is what? X bar is a sample mean. And there's two different symbols for two different mean. For example, let's say sample mean. They use X bar for that symbol. And they also have population mean. Population mean, they use the symbol mu for population mean, right? So we have sample mean and population mean. This is called X bar, this is called mu. So they use different name for they use different symbol for sample mean and population mean, right? That's what they say. So how do you estimate the population average? Remember that college students' average height question that I proposed in the first class. So because you cannot actually measure every single one and get their average, which would be mu, you rather work with a group of sample and their mean. That would be X bar, right? So X bar, which is the sample mean, is actually a point estimator of population mean. You try to estimate the mu using X bar. So how do you find the sample mean and population mean? Well, as you can see, you go to the drawing, the blackboard. So you try to figure out the sample mean using sigma x over n. And population is somewhat similar, almost the same anyway. Sigma x over uppercase n. So there's not much difference except that this sample mean is, what does sigma means? This sigma means, this symbol right here, it's called sigma. It's mean add up. So add up all the x. That's what it means. Add up all the x and divide that by what's n? This is sample size. This is sample size. If you look at the population mean, it's the same thing. You add all the x, but what's uppercase n? This is population size as well, right? So for sample size, you use lowercase n. For population size, you use uppercase n, right? And that's described in this PowerPoint. So you use lowercase n for sample, and for population, you use uppercase n, right? So let's check out this example, right? In slide numbers, page number 7. As I said, you should download this PowerPoint slide from our E360 class web resource section. You will be able to see this chapter 3 part A file, and then download this, and as you're watching this video lecture, you can take note and you can write questions, you can make your own personal note and everything, right? So you should do that. So let's say these are 70 different data points. It says 70 points. So these are 70 different data points. Let's say this describe apartment rents, right? Then how do you find the average of this? Well, if this is sample data, how do I know it's a sample data? Well, because in many cases the questions will specifically say that this is a sample data, and even here it says were randomly sampled in a small college town. This is so this is sampled. You know that it's a sample data. So how do you find the mean? Well, you add all these numbers. If you add all these numbers, that becomes this number right there, 34,356. Divide that by total number of data. How many data points that we have here? 70. So if you divide that, you get $490.80. So this is the mean value which represent this entire data set using single number, right? Okay, median is simply means the middle number, right? Middle number. And instead of using mean, which is the usual average, you can also use median value to describe the entire data set in the best way. Median simply is a middle number, and because you are only picking the middle number, it doesn't really matter if you have an extremely big or extremely small number, right? you can avoid the influence from those extremely big or extremely small number if you choose median to represent the entire data set, right? So median, let's say if you have odd number of sample, you have, as you can see, 77 different numbers, 7 sample. We arrange from small to large. You just pick the middle one, just like that. So in this case, median should be 19, right? The middle number. If the sample has even number of data points, like even observation, 8 numbers right here. You rearrange it from small to large, and you pick 19. You pick this middle two number, 19 and 20 is 6. This is fourth number, this is fifth number, right? So you pick these two and then get the average from these two, and that would be your median value, right? So 19 plus 26 divided by 2, and that's 22.5, even though that number doesn't exist as one of the sample value, but median should be the middle number right there. So, if there's like 8 numbers, then it's easy to see whether then you're gonna check actually between 4 and 5. But what if this was like not 8 number? What if this was like a 200 numbers, or 72 a different data point? If let's say 70, then what would be those middle two number, right? 70 is an even number too, just like 8. So what would be those middle two number? Well, the reason why we picked fourths and fifths is that we divide the total number of data points, which is 8. Let's see. So we divide, let me pull this one up a little bit. We divide 8 by 2, which becomes 4. So we pick fourth number, and we also pick the one bigger than this, fifth number, right? We pick these two. So if we go back to the PowerPoint slide, if there was an 8 observation, 8 divided by 2, which is 4. So we picked the fourth one and the fifth one. These two are going to be the middle two. Now, if we apply the same principle here for, let's say, this. So let's see, we have 70 different data points. 70 is an even number. So which two are going to be the middle two number? So 70 divided by 2, which is 35. So we're going to choose 35, 35th, and the one next to it, 36. So if you count it, this is 35th number, and this is 36th number. It's just that it happened to be the same number, but in many cases it won't be same. But doesn't matter. We're just going to pick the middle two, like we did in here. If it's a 70 different data point, cut it in half, divide by half, and then use that number and the next number. So 70 divided by 2, 35. We're going to use 35, 35th, and 36. Those two numbers, right, to figure out the median, the middle number. Now, there's a trimmed mean, meaning you cut off, say, if you say 5% trimmed mean, that means you cut off the bottom 5% and top 5%. That's trimmed mean. You cut off the bottom 5% and top 5%. That's a trimmed mean. So if you use a trimmed mean, 5% trimmed mean, for example, you cut off 5% the bottom, 5% on the top, you work with the middle 50%, middle 90%, right? Because you 5 and 5, 10%, you take out and you work with the middle 90%. Well, the reason why this may be a good idea is that you can avoid those extremely big value or the extremely small value, right? Now, mode of a data, mode is simply means most frequent one, most frequent one. Sometimes you don't have mode. Sometimes every number just occurs once. Then that means you don't really have a mode. Sometimes you have two numbers that most frequently occurs, and that's bimodal case. If you have more than two mode, then you can say it's multimodal. But in many cases, it's just going to be just single mode, right? And as you can see here, if you have if you use Excel's built-in mode function, it wouldn't catch the multimodal or bimodal case. So we have to be careful of that. So mode is the most frequent one. If you check 550, it's right here listed, right? Because this is rearranging in ascending order. So these two are these two numbers and these five numbers, they are all same. So 450 happened 7 times more than all the other data points. So that in that case, mode, the most frequent one, is going to be 450, right? 450. Okay.